how the throws will behave, okay, in case of checked exceptions and unchecked exceptions. If the subclass overriding method has unchecked exception, if the subclass overriding method has unchecked exceptions, then there is no rule for, okay, we need not to consider any rules for method overriding. But if the subclass overriding method has a throws with either checked exception or throwable, if the subclass overriding method has either a checked exception or throwable, then we need to consider the rules of overriding. Okay, the first we need to consider the rules of throws in overriding. Okay, just the rules will be like, if the subclass is having a throws with some checked exception, okay, either a checked exception or throwable, then the superclass should have a throws. If there is a throws in superclass but not in subclass, it will compile successfully. But if there is a throws in subclass but not in superclass, then it will not compile. But if there is a throws in subclass with either exception or throwable or a checked exception, and there is no throws in the superclass inherited method, then it will be a compile time error. Okay? But if there is a throws in the subclass overriding method and there is a throws in the superclass method, okay, then the rule should be the subclass overriding method should have an exception class which can be decreased. Okay, but as we go into the subclasses, the exception class in the throws can be the same or it can be decreased, but it should not be increased. That's the rule that we have discussed yesterday. See, here it is giving a error just because in the subclass we have a higher class. As we go on to the subclass overriding method, the exception class in throws should increase, but should decrease, but it should not increase. It should decrease, but not increase. Okay, and let me give a clone supported exception. Which is a checked exception? Now will it be compiled? Yes, just because in superclass it is exception, in the subclass it is clone supported exception, which has been decreased. It can be the same or it may decrease, but it should not increase in the inheritance hierarchy. Okay, and now what happens? Error? Will it give a compile time error? Yes? Why it is a compile time error?
Actually, it has to throw. Here, close. Corners of it is different.
Okay.
Okay, though it may throws non-point exception, that's something it has to throw separate.
Okay.
That's also true for class of the last.
Here the subclass overriding method throws a checked exception. So the superclass method should have either throws of clone or subclass exception or exception or even throwable. Now will it be compiled now? Yes. Just because since the subclass is throwing some checked exception, the superclass method should throw either the same checked exception or some super exception class. If the subclass overriding method is throwing some checked exception or exception of throwable, then the superclass method should throw the same checked exception or even the super exception class. Understood? No? Confused? See, if the subclass overriding method is throwing a checked exception or throwable, then the superclass method, the superclass inherited method should throw the same checked exception or the super exception class. Otherwise it will not be compiled. But these rules will be there. The overriding rules with the throws will be there only when the subclass overriding method, okay, throws either checked exception or throwable. Okay? No? Is the subclass overriding method is throwing an exception? Is it throwing an exception? No. Will it be compiled successful? Yes. Now, if I call a1.test, what is the output? Will it give test A or test B? Just, it's a compile time error. Just because where it will be linked to which class we have created the object? A class. Okay? Where it will be linked? A1.test will be linked to the B class test method or the A class test method? A class test method. But A class test method is throwing exception. What I told, if a method or a constructor is throwing either a checked exception or throwable, what the calling statement, we should definitely handle the exception, whatever the scenario it might be. Whatever the scenario, whether the exception is supposed to be raised or not, if we are throwing either exception or throwable or checked exception class in the throws, definitely, okay, we should handle the exception at the calling place of the method. Okay, so we are calling test method, but we are throwing the exception. Here test method is not handling the exception. So it's a compile time error here at the calling statement. So if we are calling any method or constructor, and if that method or constructor is throwing exception, means definitely we should handle that. Okay. And next, how this exception handling will be in case of constructors. Let us see how the exception handling will be there in case of constructors. Let's consider like I have a constructor A which throws a exception. The constructor A throws a exception. Now okay, now what is the output? I'll give 2 minutes, just tell the output. Huh? Just wait until the answer. What's the output? Okay. That was a very good answer. It will be a compile time error. Okay. This application will be a compile time error. What it is telling? Unreported exception, Java.long exception in default constructor. Okay. Just because, see, B has a default constructor, right? The B default constructor, let's consider like the default constructor is this. The default constructor will have an argumented super. Now where this is calling? Where which block will be executed because of this super? A class? A class which constructor? A class normative constructor. So this is the calling statement of the superclass normative constructor. But what happens in the superclass normative constructor? It is throwing an exception. Now what I told, if a constructor or method throws an exception, at the calling place we should handle the exception. Now are we calling the A class constructor in the main method? No, but the A class constructor is being called through constructor chain. So blindly we can tell that if the superclass constructor throws an exception or throwable or a checked exception, all the corresponding subclass constructors should handle the exception. Okay, if the superclass constructor throws either exception or throwable or a checked exception. If the superclass constructor throws either exception or throwable or a checked exception. Then all the corresponding subclass constructors should handle the exception. If the superclass constructor is throwing some exception or throwable or a checked exception, then all the corresponding subclass constructors should handle the exception. Just because all the corresponding subclass constructors will make a call to the superclass constructor through constructor chaining. Just because all the corresponding subclass constructors will make a call to the superclass constructors through constructor chaining. For that reason, if there is a throws in superclass constructor, then definitely all the corresponding subclass constructors should have a throws. But in this situation, what happens? There will be default constructor, but throws will not be there. Definitely, we have two options, either to enforce a constructor in the subclass or to handle the exception in the superclass constructor. Rather than throwing the exception, we should handle in the superclass constructor. That's the first option. Or in this situation, we can enforce a constructor, an augmented constructor in the subclass. Either way we can proceed, but in general, if there are no constructors in the subclass, we prefer to handle the exception in the constructors. Rather than enforcing a subclass constructor, rather than forcing the constructor creation in the subclass just for exception handling, what we do is, in general, we handle the exceptions in the superclass constructors. But if already a subclass constructor is there, if already a constructor is there in the subclass, then what we do is we handle the exception in the subclasses. Otherwise, if there is no constructor in the subclass at all, we prefer to handle the exception in the superclass constructor itself, rather than throwing the exception. Understood? At any time, we should not enforce any code. Okay, we should not forcefully put some code just because of throws or anything. If there is no subclass constructor and if the subclass is depending upon a default constructor, then definitely we will rather than throwing the exception in the superclass constructor, we will handle the exception through try catch. Understood? That's how we will do. We should not enforce any code block. Okay? This will not be compiled. So let me consider that intentionally I have a subclass constructor. Now will it be compiled? No. Even in this case, either we can throw exception Now will it be compiled? Yes? Perfect? Perfectly compiled? It will not be compiled. Just because the constructor B is throwing exception, but we are using B here. We are using the B class constructor, but are we really handling the exception here? No. So it's a compile time error. Okay, but not, this is a compile time error not because of the constructors. This is a compile time error just because we are using the B class constructor here. But B class constructor is throwing exception whenever we call the constructor, either through super this or through new operator. Either we are calling through the constructor through super and this, or through the new operator. Wherever we call the constructor, if the constructor is throwing exception, we should handle that. Okay? So now this B constructor is throwing exception, but we are not handling the exception. So it will be a compile time error, as we have shown. The B class constructor is throwing exception, but we are not handling it here. So it will be like this. Understood? This is how the exception handling will be done in case of constructor. The exception handling in constructor, okay, should consider even the constructor chaining. The exception handling in constructors should consider even the constructor chaining. Okay. The exception handling in constructors should consider even the constructor chaining. Now, the next thing is, right now what we have done is, when the runtime environment arises the exception object, we have just handled that. Okay? When the runtime environment raises the exception object, we have just handled that. Right now that is the process that we have done in exception handling. But that's not the only advantage of exception handling, but the best advantage of exception handling is, okay, we ourselves can raise the exception. Let's consider like we have a bank transaction. Okay, what's the first process? First process in the bank transaction is we'll put a card in the ATM machine. Okay. Then what it will do? It will verify the card. First, the banking application will verify the card, whether the card is a valid card or not. Okay? If it is a valid card, then the next step is it will ask for your authentication details, like what is the PIN number. So, then next verification is whether the PIN number is correct or not. Okay? If the PIN number is correct or not. The next step is if the PIN number is correct, then it will ask the user to enter some amount. Now, the next verification is whether the amount requested by the user, is a valid amount or not. That means it may be greater than the limit per day, or it may be greater than the available amount, whatever it might be. For whatever the reason, okay, the transaction may fail. Let's consider that if the card itself is invalid, do we need to proceed the transaction? No. Okay, so how we can achieve these things means, okay, we can achieve these kind of things, okay, through some exception handling mechanisms. Okay, let me show you a very simple example so that you can come to know why we need to raise the exception. Okay, so let me consider that this is the triggering point for exception handling. Let me have a class bank manager. This is the class name, and in this class we have different methods like now these are methods that I have in the bank manager. First, I will verify the card details using verify card details. I'll authenticate the user info. That means whether the user has entered the correct password or not. Authentication means just validation of the user, whether it is correct or not. Okay. Now, next I will verify the available amount in the account, whether the amount requested is matching with the available amount in the account, and if some amount is available, then I will verify whether the requested amount, whether the requested amount, okay, whether the requested amount is okay less than or greater than the amount that can be withdrawn per day. Okay, there will be a limit for any card, okay, to withdraw per day. Okay, it will be a withdrawal limit. Okay, we'll check whether the withdrawal limit is reached or not. Then at last Okay, these are my 5 methods in the banking application. Then I'll call them from the main method. Just this is a very rough example. Bank transactions will not be happen like this. There will be huge and huge and huge things in bank transactions. But just I'm telling you very rough and draft example how it will be, how the exception handling will be. Let's consider like I have a card number 11, 22, 33, 44, 55. This is my card number. Okay. Then authenticate user. Just I'll try to authenticate the user by sending the card number and just I'm sending the passcode. Okay, 0987. This is the passcode. Okay. Then I'm trying to verify available amount in the account. Okay, and I'm requesting for the amount 10,000. I'm requesting for 10,000. Okay, and verify limit per day for user. $10,000. Whether the limit per day is reached or not. If everything is successful, then I'll withdraw the amount of 10,000. Now this will be there in Bank Manager. Manager dot okay. This is my application. Okay. First, I have created the bank manager object. First, I am verifying the card details, authenticate user info, then verifying the amount, whether the amount present is there or not, verifying the limit per day for user, and withdraw amount. Just temporarily, let me hardcode that. Let me hardcode the actual values. Okay? Let me hardcode the actual values like need not to do even that. Okay, since this is a very simple application, what we do is I'll verify the card details. Okay, rather than keeping this boolean, let me keep this void. And it's not required to be boolean. Let me keep the method as void. Let's consider that the card is invalid. Okay, I have a flag, I have some calculations and I have retrieved some flag. Okay, otherwise I'll verify that the card number dot length is equal to 0. If the card number length is 0, I am considering it as an invalid card. Am I right? So just temporarily I am doing this. Okay, if card number length is equal to 0. Okay, then what I need to do is I need to block the process of this execution. Okay, when the card number is in, length is 0 means I am considering it as an invalid card. If it is an invalid card, is it correct to verify, authenticate the user info? Is it correct to ask for the password? No. Then what I'll do is, if the card number is invalid or if the card is invalid, what I'll do is, okay, I'll create an exception scenario to block the process of execution. So if the card is invalid, then what I'll do, okay, I'll create an exception scenario myself to block the process of execution, to block the transaction. If the card number is itself is invalid, I should block the transaction. So what I need to do, I'll raise the exception. Okay, I myself create an exception. I myself create an exception scenario in the application so that that transaction will be blocked. Okay, then how I can create an exception through the application? How we can create an exception through the application means just exception object, exception object, okay, with a message. Where we send a message as a string, okay, and before the exception object, okay, we should keep the keyword throw space some exception object, throw space some exception object with the message. Throw is a keyword which is used to raise the application from the raise the exception from the application. Throw is a keyword which is used to raise the exception from the application. Now, if the card details are invalid, I am throwing an null pointer exception. I am throwing exception means I am raising a new exception from the application. Rather than JVM or the runtime environment raising the exception, I am myself raising the exception through the application. How we can do that means we can use the keyword throw. We can use the keyword throw to raise a new exception from the application. Understood? Now here exception object is there. Now here if some in the 19th line if there is a null pointer exception object. Okay. Now is that null pointer exception handled here in the 19th statement? See, in the 19th statement there is an exception object, null pointer exception object. Okay. This null pointer exception object is not raised by the runtime environment, it is raised through the application by us itself. So now there is an exception object in the 19th statement. Are we really handling at the 19th statement? No. Now if there is a handle unchecked exception object in the method, what happens? If there is a unhandled unchecked exception object is there in the method, then what happens? What happens? Stack unwinding happens. Because of stack unwinding, ducking happens and the exception object will be propagated to the calling place. Now, to which line this null pointer exception object will be propagated? To which line this null pointer exception object will be propagated? Here, just because from here we have called verify card details. In the verify card details method there is a unhandled and null pointer exception object. So this exception object will be propagated to 7th line. Now in the 7th line are we handling the exception? Are we handling the exception? No. So since we are not handling the exception, Okay, just let me try to execute the application and show you. Sorry, this will be erased only if the card number is 0. If we provide a valid card number, then it will not raise any exception. Let me provide a card number which is blank. So, if it is blank, the card number length will be 0 and the exception object will be created. Now what happened? There is a null pointer exception which was unhandled. Okay, so is the specific transaction blocked or the whole application will be blocked? If there is an unchecked exception, if there is an unhandled exception, is that specific transaction blocked or the whole application will be blocked? Whole application will be blocked. The whole banking application will be blocked. If there is an handled exception object, then definitely the whole application will be blocked. But is it correct to block the whole application? Is it correct to block the whole application just because one of the transactions has invalid card? Is it correct? No. Yes? It's not correct, right? Just because of one card is invalid, it's not correct to block the whole banking application. So what we'll do, rather than leaving the exception as it is, what we do is, we have a try. The whole process will be there in the try, and in the catch, we have now, if null pointer exception is raised means, just I am displaying a message that please reinsert your card. Null pointer exception is raised means, here what the null pointer exception represents? It's an invalid card. So, in the catch, I am telling that please insert your card. Okay? Now, let's consider that if the card number is invalid, will it block the process? Will it block the transaction? If the card number is invalid, will it block the transaction? Yes, just because since the card number is invalid here we are raising a null pointer exception, but here we are handling the null pointer exception. Since the null pointer exception is handled, will it go back to the try? If the null pointer exception is handled, will it go back to the try? No. If it is not going back to the try, are all these processes handled? No. All these processes will not occur. Just because in the first step itself, since the card number is invalid, in the first step itself, just because of the card number is invalid, the remaining steps will not occur. Let's consider like the card number is valid. Let's consider like the card number is valid. Okay, and even for pin code also I am doing the same thing. Whatever the passcode he enters, which is whose length is equal to 0, Then let me raise a class cast exception for invalid passcode. Okay, I am representing class cast exception. Okay, for exceptional scenario, invalid password. Okay, now what happens if the password length is 0? Then I am telling that it is an invalid password for now, but it's not the process. Just I am telling it as a basic example. Okay, now let's consider like I am not entering a valid password. Now what happens? Will it block the process of execution or will it just block the transaction? Will it block the process of execution or will it just block the transaction? The process of execution will be blocked just because here the card number is valid. Just because the length is greater than 0, it will not to come to you. It will succeed the card details. Now again it will come here and we are authenticating the user information. Here we are sending some card number and some password which is blank. Now if the password is blank, then what I am doing? I am raising a class cast exception. But am I handling the class cast exception here? Am I handling the class cast exception here? Yes? No, I am not handling the class cast exception. It's a catch with null pointer exception. So the execution itself will be blocked. The execution itself is blocked. So what I will do? I will write a catch with the class cast exception. Okay, and I'll generate this. In the catch in general, what we do is we'll construct the message to the user. Okay, whatever the message that is to be displayed for the user, we'll construct the error message. Okay. Please enter valid password. So if the password is invalid, then what I am doing is I am raising a class cast exception and I am telling that password is invalid. So let's consider like the card is a valid card, but the password is invalid. Okay. Do we need to really proceed the transaction? No. So now will it proceed the transaction or will it block the transaction? It will block the transaction just because here we have authenticate user info. The authenticate user info, what we are doing, we are getting the passcode, and if the passcode length is 0, then I am raising a class cast exception. Now am I sending the passcode as blank? Yes. So will it raise a class cast exception? Yes. So this class cast exception will be propagated from here to which line? 9th line. In the 9th line there is an there is a class cast exception. So now do we have a catch for class cast exception? Yes. In the class cast exception, the exception will be handled, but here we are displaying the message to the user that the password that is entered by you is invalid. Now let's consider like I am sending even a valid path. So now let's consider that. See, I am sending a message that please enter valid password. Understood? Understood up to here? Everybody? Is there any confusion or understood? Just speak out, man. Just speak out frankly. If you are not getting, we can explain it once again. Understood? Everybody? Now, let's consider that the password is valid. The password is valid as well as the account is valid. Then we go for amount. Verify available amount in account. Okay. Now let's consider like the available amount is 5,000 rupees. Then I will do like if amount requested is greater than 5,000 rupees. then I'll throw exception by sending a message that amount requested is greater than the available. Yes, I am sending a message that amount requested is greater than the available. So, if amount requested is greater than 5,000, then I am raising arithmetic exception. Let me handle the arithmetic exception here. Okay, just let me paste the same message. Now, what is the amount that I am requesting? 10,000. Is it greater than 5,000? Is 10,000 greater than 5,000? Yes. So, will it raise arithmetic exception? Yes. Now, the card is correct. Authentication is correct. The user has entered the correct password. But I am entering amount which is greater than the available amount. Which is greater than the available amount. So, what happens? What happens here? Where it will go? Where the execution will go? Will it reach the end of withdraw amount or will it go anywhere? Where it will come? It will come to which catch? Third catch. Just because I am sending amount which is 10,000, but here I am verifying whether the amount requested is greater than 5,000. Available is 5,000, but I am requesting 10,000. So what I am doing? I am raising arithmetic exception, and we have a catch with arithmetic exception. Okay? So in the catch I am constructing a message that the amount requested is greater than the available amount. Actually the available amount is 5,000, but we are requesting for 10,000. So is the transaction blocked in this scenario? The card is valid, the password is valid, but the amount is greater than the available resource. So the transaction should be blocked. Okay? And we are blocking this transaction very simply, very flexibly through exception handling. Okay? So now let's consider like I am entering a valid amount. I am entering a valid amount which is 4,000. Now, let's consider like for that user, per day he can withdraw only 2,500 rupees. For that account, the user can withdraw only 2,500 rupees per day. Okay? Let me write the condition. If the amount requested is greater than 2,500 rupees, then let me throw a index out of bounds exception. Okay, let me throw an index out of bounds exception and let me handle it here. Okay, is greater than the limit per day. So just I am raising index out of bounds exception when the amount requested is greater than the limit per day. So now what is the amount that I have requested? What is the amount that I have requested? 4,000. What is the limit per day? I have 2,500. Now, will it raise the index out of bounds exception? Yes. So this index out of bounds exception will be propagated from here to this statement. Okay. Now here, do we have a catch of index out of bounds exception? Yes. Here we are displaying the message to the user that the card is valid, the password is valid, you have some money in your account, but your limit per day is 2,500 only, but you are trying to withdraw 4,000, which is not a valid scenario. Okay. Now let's consider like I am withdrawing only 2,000 rupees. I am withdrawing only 2,000 rupees. Okay. Now just I am telling that withdrawal is successful. Withdrawal is successful. If the application crosses all its exceptions, if the application crosses or if the transaction crosses all these exceptions, then only it will become a successful transaction. Let's consider like the transaction failed to satisfy any of these conditions, or if at any of the steps, if exception is raised, then is it a valid transaction? No. So at that point of time itself, the control will come to the cache and it will never go back to the drive. If there is any exception at any point, whether the CAD is not valid or the passcode is not valid or the amount is less than the available resource or the amount requested is greater than the withdrawal limit per day, for any reason, okay, if there is any exception means, okay, the control will come to the cache block and it will not go back to the drive block, so that the amount will not be withdrawn. So this is how the exception handling will be used in the real-time applications. This is the best way of using the exception handling to process the transaction. Understood? Understood? This is how the exception handling will be used in the applications. Exception handling is not just the runtime environment raises the exception and we handling the exception. That's a very minimal usage of exception handling. But the real advantage of exception handling is we raise the exception when the exceptional scenario arises. We raise the exception when the exceptional scenario arises and we handle the exception at the very root place. See, rather than handling the exception at multiple places, what we are doing is we are handling the exception at a common place and we are constructing the message to the user. When the exception scenario arises in the application, okay, we raise the exception and we handle the exception at a common place, and at the common place we construct the message to the user that because of so and so problem I could not able to proceed the transaction. Okay, this is the correct usage of exception handling in the applications. Understood? Okay. And now what I am doing is, if the card is invalid, I am representing that situation through null pointer exception. Now, is it a valid thing? See, null pointer exception has a specific purpose. If null reference is there, and through null reference if we are referring an attribute or a method, okay, then it is a null pointer exception. Null pointer exception has a specific purpose. But what we are doing, we are representing the invalid card through null pointer exception. It's not a correct thing. In the same way, class test exception also. The class test exception has a specific scenario. When invalid typecasting happens, we should raise a class test exception. But is the class test exception raised here because of invalid typecasting? No, because of invalid password we are raising class test exception. All the exception has a specific purpose. But we are using the exception classes which are there in the library for our purposes, for our specific purposes. Is this invalid card details, or is this invalid password, or is this invalid amount? Are these things specific to the application or generic to all the Java applications? It is specific to the specific banking applications. These are not generic to all the Java applications. Java can be used for any application, banking or healthcare or insurance or automobile or mobile or any kind of application. These things, these exceptional scenarios are not generic to all the applications through Java. These exceptional scenarios are specific to that application. If there are exceptional scenarios specific to that application, we should not represent them through generic exception classes. Okay, these are the exception classes which are there in the library, which have a specific meaning and which have a specific purpose. We should not use those exception classes which have a specific meaning to represent the application specific exceptional scenarios. We should not use those exception classes in the library to represent the application specific exceptional scenarios. So for that purpose, what we need to do is, okay, we need to go for a custom exception. Custom means user defined. In any software application, custom means user defined. Okay, custom means user defined. Okay, we can create a user defined exception, or we can create an exception in the application. What is the custom exception means? The exception class which is created in the application is called as a custom exception. Custom or user defined is one and the same. Okay, custom or user defined is one and the same. Custom or user defined is one and the same. Custom or user defined is one and the same. So we can, rather than depending upon the exception classes that are there in the library, we can create our own application specific to our application. We can create our own exceptions specific to our application. Those exceptions are called as custom exceptions or user defined exceptions. The exceptions that we create in the application are called as custom exceptions or user defined exceptions. Custom exception or user defined exception. Throw or throws? See, throw will never be used to handle exception. Throw will be used to create the exception.
Actually, if B is there, if B is equal to 0, then we can close. Then how can we add it? Only add the whole class, only main method.
Okay. See, if A by B is equal to 0, you need not to handle the. See, the process, anywhere, the process will not occur in a single method. Anywhere, in any application, it's not realistic to have the whole process in the same method. In any application, the process will be distributed into some different chunks, different methods. So, never, in any application, it will never be like that the process is there in the only one method. The process, any process will be distributed into multiple chunks, multiple parts. And each and every chunk will be there in a method. Okay? It's not like the whole banking transaction will be done through a single method. That's not realistic scenario. Okay? How we can create a user-defined exception or a custom exception? Now, in order to define a custom exception, okay, already we told that each and every exception is being represented by a class. So let me write a class which is the class name should represent why we are using the class. Invalid card exception. Invalid card exception. And all the custom exceptions should be a subclasses to runtime exceptions. Why we should make a custom exception to be a subclass to runtime exception means we need not to handle the process of ducking if it is a runtime exception. If it is extending to runtime exception means which type of exception it is? Is it a checked or unchecked? Unchecked. If it is extending to runtime exception means definitely it will be a unchecked exception. For unchecked exceptions, do we need to handle the process of ducking? No, we need not to handle the process of ducking. It will be done automatically. But if we make it a subclass to exception, what happens? It will become a checked exception. If it becomes a checked exception, then what happens is again and again we need to handle, we need to propagate the exception using throws, which is not a valid approach. Okay, in general, if it is a custom exception means it will be a runtime exception, or it will be a subclass to runtime exception, or it will be an unchecked exception. In most of the scenarios, 99% of the scenarios, if you are creating a custom exception means definitely it will be a subclass to runtime exception, or it will be an unchecked exception. In most of the scenarios, custom exceptions will be unchecked exception. If we specifically require a checked exception, then we extend the exception class with exception. Okay? If we specifically require a checked exception, a custom checked exception, then what we do is we extend the custom exception class with java.lang.exception. Otherwise, in most of the scenarios, the custom exception will be unchecked and it will extend to runtime exception. If you specifically require a checked exception, then the custom exception class will extend with java.lang.exception. Now, we should have a constructor which takes a string message invalid card exception which takes a message. And we should call the superclass constructor by sending the message. Okay, so this is how we can create a custom exception. This is how we can create a custom exception class or user defined exception class. Why we are calling the superclass constructor means just to display the message in specific format. Okay, we have a specific format like at this line there is a exception and because of this reason, and for that format, for that exception format, just we call the superclass constructor. When exception is occurred, you have observed multiple times. When exception is occurred, the message will be displayed in the console in a specific fashion or in a specific format. Like at this line, some exception has occurred because of this reason. Okay, for that formatting, we call the superclass constructor. We call the runtime class constructor. Okay. Now, I have created a new exception class which is invalid card exception. Now, when the card number is invalid, what I'll do is I'll throw invalid card exception. Okay. Now I'll handle invalid card exception. Okay. Now just let me print the stack trace. In general, when we handle the exception, we print the stack trace. Okay. Now, what we are doing, we have an invalid card exception, and we have a constructor in the invalid card exception which takes a message and which extends to runtime exception, and we are calling the superclass constructor, runtime exception class constructor, by sending a message to construct the specific format of the message. Okay. Now. Okay, just let us see by sending an invalid card. Now I am sending an invalid card. If I send an invalid card, what happens? If the length is 0, it will raise a new invalid card exception. If invalid card exception is raised, it will come to this catch and it will print the stack trace. Let me see by executing the application. Just to display the message in this format. Okay, what we do is we call a superclass constructor here. Understood? So it tells that there is exception. Okay, com.su.invalid card exception, which is okay invalid card. Okay, then I am asking to verify the card details. At this line there is a exception, but the remaining things will be processed. It reaches the catch, but the remaining things will be processed. Okay. Let me keep the system.out.println after here. So just let me go to SRC, compile the application, and go to the classes and execute the application. Now is it coming to end? That means is the transaction is blocked, but is the application blocked? No, the application is still running. The application will be still running for other transactions. Understood? Now let's consider another scenario where the password is invalid. So invalid password exception. Okay, invalid password exception. So when I will use invalid password exception to represent a specific exception scenario, and using class exception to represent invalid password, I'll create a new exception class which is invalid password exception. Okay, and I'll handle invalid password exception and I'll print the stack trace. Okay, so I have created a new exception class which is invalid password exception. I am raising the invalid password exception when the password is invalid, and I am handling the invalid password exception here, and so the transaction will be blocked, but the execution will be normal. Here the invalid card exception is still there just because we are sending an invalid card number. Now let me send a valid card number but invalid password, which is blank. Okay, now let me go to SRC, compile the application, go to the classes and execute the application. So here it is telling that it is a invalid password exception and the message is invalid password. Understood? Okay, like that we should create an exception class for each and every specific exceptional scenario in the application. For each and every specific exceptional scenario in the application, we should create an exception class. Now, available amount is invalid. So, My level amount invalid exception. Okay. So the exception class, by seeing the exception class, can we come to know what type of exception it is, why exception is raised? So the exception class should reflect the purpose. Okay, why we are using the exception. This will go with print strictness. So now let's consider like the card is a valid card and the passcode is valid, but we are requesting for 7,800, which is an invalid amount. Okay, the amount is invalid just because the limit available is 5,000, but we are requesting 7,800, which is invalid. So let me go to this, see, compile, execute. So here the amount available is invalid. So now let me go for the last one. Withdraw limit exceeded exception. Okay, let me bring the strike test. In general, in software applications, we won't use system.out.println. In software applications, in the industry, in any Java application, nobody will use system.out.println. The system.out.println is just for our purpose. Okay, for some test applications, that's it. No one will use system.out.println in the software applications, in real-time applications. Okay. Now, let me define another class, which is withdraw amount exception. Just I have created a class withdraw limit exceeded exception. By seeing the class, we can come to know that okay, the withdraw limit is exceeded. Okay. So now let me enter a valid amount 3,000, but the withdrawal limit is exceeded. So now 3,000 is a valid amount, but the withdrawal limit is 2,500, but we are trying to draw 3,000, which is a exception scenario where we are withdrawing the amount greater than to our limit per day. Okay, so like this, for each and every exceptional scenario, we'll write a custom exception class and we will raise that custom exception when that scenario arises. When we come to know that scenario arises means when we execute the business logic. When we execute the business logic, then only we can come to know that the exception scenario arises. When that exception scenario arises, okay, we create or we raise a specific exception object. Okay, and that exception object will be handled at the root place, and at the root place what we do is we handle the exception and we generate the message that we need to display to the user. Understood? This is how the exception handling will be used in the real-time applications. Okay? Understood? Okay. Now, the last concept in exception handling is rethrowing the exception. Rethrowing the exception. Rethrowing the exception. Yes, it will go to the runtime exception class constructor. Yeah, this message is being constructed. See, this message format is there, no? This message format is being constructed in the runtime exception class constructor. Okay? Now, the last concept in exception handling is rethrowing the exception. Okay, let's consider that. I have two methods. Process transaction is one method. Then once the transaction is processed, we need to keep the history of the transaction. When the transaction is occurred and where the transaction is occurred, at what time the transaction is occurred, what is the amount, and from which account to which account the transaction is being occurred. That kind of thing is called as audit. Okay, that history that we maintain is called as audit. For any future purpose, let's consider like after 1 year, I'll ask for bank transaction, bank statement. Like, okay, please give me the bank statement for the past 1 year. How they can fetch the bank statement? So they'll maintain the history. Like, at this time you have tried to perform this transaction. At this time I have performed this transaction. This kind of history will be maintained in any application. Okay. So we'll process the transaction. If the transaction is successful, then I'll audit the transaction. So let's consider like I have some unsuccessful transactions. Will I show that in the bank statement? If you have some unsuccessful transactions, are those transactions shown in the bank statement? No. Unsuccessful transactions will not be shown in the statements. Unsuccessful transactions will not be there in the audit. Only successful transactions will be there in the audit. So let me try two methods. One is process transaction, another is audit transaction. Now let me develop this method. This I am writing process transaction where I am calling all these methods. Okay, where I am calling all these methods and I am calling even audit transaction. Now what I am doing here I am having two methods. One is process transaction, another is audit transaction. I am calling the process transaction, and from the process transaction we need to go this just because it is the same class. Since it is the same class, we need to have a reference to call the method. Now I am calling process transaction. In process transaction, what I am doing? I am doing all the activities of the transaction. So now from here I am calling the process transaction. Okay, will it be the same or will it behave different? Will it be the same or will it behave different? It will be the same. Writing all the things in the try or writing all the things in a method and calling the method from the try block, it will be the same. It will not be different. Okay. Now what I am doing is, in order to verify the card details, let's consider like in order to verify the card details, I am opening a file. I am opening a file whenever I am opening a file. Okay, I am opening a file whenever there is a card detail. Sorry, whenever we want to verify a card detail, I am trying to open a file. Okay, I am trying to open a file whenever there is a card detail. Then what happens is, let's consider like there is an exception in this scenario. Let's consider like there is an exception. Okay, let's consider like there is a exception, and at the end I am closing the file. To perform some transaction, what I have done is I have opened a file. I have opened a file which will be used to perform the transaction, which will be used in the process of transaction. In the process of transaction, this file will be used for any purpose. For any purpose, it's irrespective. I have opened a file which is used in this transaction. Now, what I am doing is I am closing the file at the end of the transaction. Okay. Now, let's consider like if there is any exception. Let's consider like there is any exception. If there is some exception, now is that file closed? Will that file be closed? No. Just because, let's consider like there is an exception where we are requesting for 3000 rupees, but the limit per day is only 2500. So there is exception which is withdraw limit exceeded exception. See, we are requesting for 3000 rupees, but the withdrawal limit per day is 2500. Now it will be a withdrawal limit exceeded exception. Now if that exception arises, now is that file closed? Will that file be closed? No. So what we do is, in general, okay, since this file will be still open, this file will be closed only if the control reaches the end of this statement. But this end of this statement will not be reached if there is an exception. Right? So what we do is, in general, we temporarily cache the exception. We temporarily cache the exception and we write the logic to close the file. We write the logic to close the file and throw the same exception. Okay, since this logic is same for all the exceptions, either whatever the exception it is raised, whether we raise an invalid card exception or invalid password exception or available amount invalid exception or withdrawal limit exceeded exception, for any exception the process is the same. Just when exception is there, just we close the file and we raise the same exception. Just we close the file and we raise the same exception. Okay, just we close the file. Rather than doing this, just what we do is we go for specific things, like let's consider like we have withdrawal limit exceeded exception. Okay. Now, okay, otherwise that's fine. Now I have withdrawal limit exceeded exception. Now what I am doing is, okay, see, I am opening a file and I am closing the file at the end. Okay, but intermittently there can be some exceptions. There can be some exceptions. Okay, so when the exception is raised, it will not reach the end of the statement. So what we do is, we temporarily cache the exception, we write some logic and we throw the same exception from the cache. Whatever the exception that we are handling, we raise the same exception object. We are not creating a new exception object here. We are handling an exception object temporarily and we execute some logic and we raise the same exception. Handling an exception, executing some logic and raising the same exception is called as rethrowing the exception. Already the exception is there. What we are doing is temporarily for some purpose we are handling the exception and we are executing some logic and we are raising the exception again. We are raising the same exception. That's how rethrowing exception is. That's what rethrowing the exception is. Handling an exception, executing some logic and throwing the same exception again from the cache is called as rethrowing the exception. Handling the exception, executing some logic and throwing the same exception from the cache is called as rethrowing the exception. Simply throwing the handled exception from the catch block is called as rethrowing the exception. Throwing the handled exception object from the catch is called as rethrowing the exception. Throwing the handled exception object from the catch is called as rethrowing the exception. We are not creating a new exception here. Whatever the exception object that we handled, we are throwing the same exception object. It's not creating a new exception object, it is rethrowing the handled exception. It is rethrowing the handled exception object. Here we are rethrowing the handled exception object. That's it. We are not creating a new exception here, we are rethrowing the handled exception object. To rethrow exception, obviously we should have a try and catch.
When we do the exception, we are doing we are doing the exception. We throw, we don't put that in try block.
No, if you are rethrowing the exception will be rethrown from the catch block, right? See, handling the exception from the catch and throwing the same exception from the catch is rethrowing.
Throwing in the sense, not to put that in try.
Throwing in the sense?
Throwing is, if you want to handle that exception, we have to put that exception in try block, we have to some catch statement regarding that. Right. Here we rethrowing the exception, but we didn't put that in try block.
We did not move that?
We did not put that in. I mean to say that the exception in try block, where we handle that.
See, here it is there, right? See, this verify per day limit for user will be called here. This verify limit per day user will raise the exception. This exception will be propagated from here to here. There is exception object here. This exception object will be handled through this catch. Again we are throwing the same exception. But where this exception will go? See, here we are raising the exception. There is an unhandled unchecked exception object here. Where it will go? It will go to the calling place. From where we have called this method. See, wherever it might be, there is an unhandled unchecked exception object. The stack unwinding happens and the ducking happens, and the exception object will be propagated to the calling place. Now, are we handling the exception object which is raised here? No. Here we are throwing the exception, but we are not handling the exception object here. This exception object will be propagated to process transaction. This place. So here we are handling the exception here, and this exception will be handled. Understood or not? Okay? So this is how rethrowing works. We use rethrowing only if we want to write some business logic in the middle. Okay? If you want to write some business logic in the middle of handling exception, okay, then we catch the exception, we write that logic, and we rethrow the same exception. Okay, this is how the exception handling will be useful, and this will complete the exception handling. Okay, and in the next class we will discuss about the object class. Okay, we told that Java.lang.object is a superclass class for all the classes in Java. Why it was made as a superclass? What is the importance to make that object class as a superposed class to all the classes in Java? There might be some advantages of object class. We will discuss about the advantages of the object class and the methods in the object class, how they behave, why they are useful. All these things we will discuss. Okay, in the next class. Actually, I have an unplanned commitment. I need to go to my hometown today night. Okay? And it was not priorly planned. I just have got the information yesterday. I need to go to hometown also. Even I have an unplanned leave in the office. So there will not be class for these 3 days. We have a class on Mondays. Okay? If we had the classes on Monday and Tuesday, we might have completed this object class, but unfortunately, because of power failures, we did not have classes. But let's hope better that power will be there at least for the next 1 hour. But for these 3 days, we don't have any classes.